Hello students, the purpose of this video is to do a quick overview of quadratic functions. So a function that is quadratic is defined by f of x is equal to ax squared plus bx plus c, where a, b, and c are constant terms. If the highest degree that I see in the equation is a 2, then I know that I am working with something that is called a quadratic function. There are several ways that I can write a quadratic function. The way that I've highlighted in pink is my standard form. That's the way that we generally work with quadratic form. But we also have vertex form, and that is written as a times x minus h all squared plus k. So there's some information that we can know about our different values. If the value of a in either format is bigger than 0 or less than 0, that helps us determine how our parabola looks. The parabola is the shape of a quadratic function. So this U shape that you see down here, that represents a quadratic function. If the value of a is bigger than 0, your parabola is opening up. That means you're going to have a minimum point. If the value of a is less than 0, your parabola is going to go down, so you have a maximum value point. There is an axis of symmetry. It's going to go right down the middle of your parabola, and it corresponds based off of what your coordinate values are. So if I'm identifying the minimum or the maximum point as the coordinates hk, then that lets me know that the axis of symmetry is going to be the h value of that coordinate, and that's the line x equals h, whether I'm dealing with a minimum or a maximum value. I didn't highlight this first bullet point where I've put a star because it can vary based on how you find your vertex. So of course every vertex can be identified as h and k, but again it could vary depending on how you're going to find that based off of the particular function that you have and the form that you're given the function in. That's going to make a little more sense as we do some problems. I know that probably sounded super confusing, and I apologize about that. So why would we care about this? Well, quadratic functions are super useful. We've talked about linear functions before, and we love linear functions because they have this sense of perfectness. We have a slope, we have a rate of change, it's a constant rate of change, it's consistently changing, easy to predict things that may happen in the future. We really appreciate those, but not a lot of things in life are represented by linear functions because we don't live in a perfect world. So a quadratic function is a more useful type of function that you may come into context with more often when doing real world type problems. It is often used as a model for projectile motion. So if you actually look at this human picture here and he's throwing a basketball, it's going to follow a quadratic pattern. I'm sorry, my line is so wiggly, but it has that quadratic parabola format where it's going to reach like its peak point somewhere around here. That would be its max, and then it's going to start falling again. And so there was actually this movie, I'm trying to think, I think it was called Ice Princess. If any of you have seen that or remember that movie, it's been quite a bit of time since that movie came out, but Ice Princess, that was her whole goal, was to try to develop mathematical equations based off of figure skating, and that was to help her learn how to figure skate. So she never learned it, like nobody ever taught her. She just used all of math and physics to determine these equations that would help her understand how she could become a figure skater. And so a lot of things that we do, we don't really think about it in a math context, but a lot of it does have math context to it. So I encourage you to pause this video to match each graph with its correct function. Honestly, this is a review of transformation of functions, but I want to make sure you feel comfortable doing this because you are working now with quadratics. So you want to, again, make sure you feel comfortable with transformations. So if I think back to the parent function of a quadratic, I know that the parent function is f of x is equal to x squared. So I want to see how each of these equations change. So I'm going to kind of skip around. I'm going to do things that to me are just a little simpler. So you could either go by the equation and then find its matching graph, or identify what the equation has done, like on its graph, and then find the algebraic equation that matches. So I know that on letter A, I have reflected, and I have reflected across the x-axis. I know that I have moved 4 units to the right, and it appears that that's all I've done. So I'm going to look at my choices for 5, 6, 7, 8 and see which one shows me that I've reflected across the x-axis and that I've moved 4 units right, and that is number 8. So number 8 corresponds to letter A. On letter B, it appears that I have only moved up 3 units, and I apologize, you guys hear Bento in the background, but it appears I've only moved up 3 units, so that corresponds to letter or number 7, so 7 is B. Letter C, it appears that I've moved right 2 units, and so if I've moved right 2 units, that is number 5. And on letter D, it appears that I've reflected across the x-axis, and I've moved up 3 units. And if I, obviously by process elimination, the only other option left is for number 6. And that does in fact match that description. Okay? All right, so some more review. What do I do when I want to find the x-intercepts? Or what if I want to find the zeros of the function? Or if I want to solve a quadratic function? Well, in all of these, I'm essentially asking you to do the same thing. When we are finding the x-intercept, we know that we're looking for an x value when y is equal to 0. When I'm asked to find the zeros of a function, we know that y is equal to 0, and we solve for x. When we solve a quadratic function, we set the entire function to y equals 0. So what I'm trying to get you to understand is I can ask directions in several different ways. I can say find the zeros, find the x-intercepts, solve the quadratic function, but literally in each of these, all I'm asking you to do is solve when y equals 0. And so what you're doing is solving for x. And you plug in y is equal to 0. So all of these 3 statements are synonymous to one another. So what you're going to be doing is you want to feel comfortable being given a problem such as this. F of x is equal to negative 2 times the quantity x minus 1 all squared plus 8. And you want to be able to answer each of these portions of questions. So I'm going to take it step by step, but again, I encourage you to pause this video, try to work on your own. Don't wait for me to do everything, and see if you're able to work through it. So part A wants you to determine whether the graph of the parabola opens up or downward. Well, what we know is we want to concentrate on our A value and determine is it greater than 0 or less than 0, because that will tell us if we open downward or upward. So when I look at the value of A, I see the value negative 2. That is smaller than 0, therefore my parabola opens downward. In part B, we were asked to identify the vertex, and we know that when we are looking at the vertex, we are focused on the values h and k. So that means from this equation, if we go back to our original equation, our values of h and k are 1 and 8. Now, you may be noticing, like, hold on a second, I see a negative sign here. So this, like, negative sign, why are we not writing -1 and positive 8? Well, remember that the way this equation is written is the format is x minus whatever h is, all squared, and my a is here, plus my k. So I'm not focused on that minus sign. That minus sign is always there. I'm focused on whatever is here. I do want to look at that sign, because if that sign changes to a plus, that's going to tell me that I had to put in a -1. So what I mean by that is, let's pretend we had -2 times x plus 1 all squared plus 8. I would look at this and I would still only be focused on this term, but I would notice here in orange that I have a plus sign. And I would think to myself, wait, that's an issue because it's supposed to be x minus my h term. But I have a plus. So the only way that could have became a plus sign is I must have put a -1 in here. So that means my h value in this case was equal to -1. So you have to be careful of that. You do want to concentrate on that sign, but the sign doesn't necessarily go with the value in the vertex. And that can be a little tricky. I've also heard people think about this as being the opposite. So I'm going to get rid of all this for a second. That whatever you're identifying as your H and K is opposite of what you see. The only problem with that is, yes, that's true for your H value. It is not true for your K. Like, I want to keep the K as written. So if you remember that your H value is always opposite of what you see written, including the sign here. So -1, that means my H is +1, and then K is literally what I see. Then that's a way to think through it as well. So I'm trying to give you a lot of different options on how to think about this. You're just going to have to pick whatever works best for you. In part C, you were asked to find the x-intercepts. So if we are trying to find the x-intercepts, we are looking for the coordinates that represent a number and 0, because the y value is always equal to 0. So you see I've taken my equation, I've set it equal to 0, and then I'm literally going to begin solving. At this step right here, notice that I had to put in the square root, and whenever I put in the square root, I have to make sure I put that plus or minus. Super important, because that's how I get to my final answers of x equals 3 and x equals -1. I would not get 2 solutions for my x-intercepts if I didn't remember to put in that plus or minus sign. In part D, you were asked to find the y-intercept. So again, as a friendly reminder, that means that your x value is 0 and you're looking for some number as your y value. So I went ahead and plugged in 0 for x, and I solve, and I get a final y-intercept value of 6. In part E, you're asked to graph. So we've already identified our vertex point. We have found our x-intercepts, and we found our y-intercepts, so we can easily connect all those points together to create our parabola. You'll notice here in pink that I have also put your axis of symmetry, which is going to go through your max value, which is your maximum vertex point. And that last question does ask about the axis of symmetry, which makes it very easy to see when you draw the graph. And so we see we have a max value. We can identify our axis of symmetry very easily. And then now that I have a graph, I can identify my domain and range. So this arrow is headed to the left. This arrow is headed to the right. And this arrow is headed down. This arrow is headed down. And the highest value is over here at 1,8. So I'm actually going to just box in 1,8 because that's my max value. And so if I want to identify my domain, I'm concentrated just on my x description terms, which is going left to right, and then the value 1. So the smallest number out of all of that is left, that's -infinity. The highest value out of all of that is right, that's +infinity. And then if I want to identify my range, I'm thinking about up, down. So down are my lowest values, and then the highest y value is 8. So down represents -infinity, and then the highest is 8. And 8 is a vertex point that is included, so I'll use a bracket. A lot of people ask me, do I need to make 2 separate intervals because I have this description down and then this description down? No, because in reference to height, both of them are headed down, which means both of them are going toward -infinity. So I only need the one descriptive term. All right, so here is another example. I got rid of letter A, but I've asked you to find the following. So I encourage you again, pause this video. It doesn't help you to just listen to me kind of go through this, especially since I am going through this a little quickly. You do want to make sure that you're working it out. That's how you're going to learn the material. So part B asked me to identify the vertex, and we know that the vertex is represented by HK, and we said one way we can remember this is whatever is written in the H spot, I want to take the opposite of it, and I'm going to keep K as is. So when I look at H, I see a positive 2. That must mean that my vertex point is the opposite, which would be negative 2, and K is as is, and I see negative 7, which we see right here. Then when asked to find our intercept values, for x-intercept, we are going to set our y value equal to 0. So the entire equation, that quadratic, is set to 0. You could try to factor or factor by grouping. In this case, I chose to use the quadratic formula. So all those things you learned back in one of our earlier units, you don't want to forget. Go through all the work by identifying your A, your B, and your C and plugging it into your quadratic equation respectively. And you don't get very pretty answers. They're not very nice, but nevertheless, they are still x-intercept values. Okay, so even if they're not nice, pretty numbers, that's okay. Looking at y-intercepts, I'm taking all of my x's and I'm plugging in 0 for them in order to find my y-intercept value, which ends up being equal to 5. If I go to graph, I want to graph my x-intercept values, I want to graph my y-intercept value, and I want to graph my vertex value. If I connect everything together, I've easily created my parabola. I can split that thing right down the middle going through my vertex, and that is my axis of symmetry, and that is the line x equals negative 2 because it corresponds to the x value in my vertex coordinate. There is a minimum value here. That value of A is positive 3, and 3 is bigger than 0, so that lets me know that this thing is going upward. Therefore, I have a minimum value. And then if I wanted to identify my domain, this is headed to the left, this arrow is headed to the right, and this arrow is headed up, this arrow is headed up, and then we have our vertex value. So left to right are my lowest and highest x directions. So that represents negative infinity to infinity. And then up, and negative 7 represent all my y values. So the lowest one is negative 7. It is included because it is a vertex point, and then up is represented by infinity. I did want to give you one more method to finding the vertex because we learned this H and K process, but what if I don't give something to you in vertex form? Instead, I give something to you in standard form as I did here. Well, the formula, all you have to remember is that you get your x coordinate by doing negative b over 2a, and then that gets you your x. You plug it into your original equation and solve to get its corresponding y value. So negative b over 2a. So looking at this equation, I would want to identify what is a, what is b, what is c. Similar to how you do for the quadratic formula. And that's negative 1, that's 4, and that's negative 5. Okay? So then my x coordinate for my vertex, so we're trying to find vertex here. The x coordinate value is equal to negative b over 2a. So negative whatever my b value is over 2 times whatever my a value is. So b is 4 in this case, and my a value is negative 1. And if I simplify this, that's negative 4 over negative 2, which is equal to positive 2. So this represents the x value. So to get the y value, I'm going to go back to my equation, negative x squared plus 4x minus 5. And everywhere I see an x, I'm going to plug in this x value that I just found. So 2 goes here, 2 goes here. 2 squared is 4, so negative 4 plus 8 minus 5. Negative 4 plus 8 is positive 4 minus 5, and that is negative 1. So now I can put my x value and my y value together to create my final vertex coordinate, which would be 2, negative 1. Alrighty, I hope that everything was understandable in this video. As always, if you have questions or concerns, I'm happy to assist. Just let me know. I hope you have a wonderful rest of your day.